They're on wheels that are pretty good. It's pretty low friction, except for these cables, I suppose. Might drag on that. Okay. And on the carts, we have two force sensors. And I've got software. The force sensors are connected up to this thing here. Okay, this should be communicating with the two force sensors, and you can see on the left-hand side there's the two sensors. And they're not zeroed properly, so I'm just going to force them to go to 0. And they should now be 0. Okay, and you can see as I push in on them, this one, I guess, is sensor 2. I can apply a force there. And this one is sensor 1. I can apply a force there. And if I apply a force the opposite direction, it has the opposite sign. Okay, so I've also got things like these weights here I can mount onto them. I've got some clay I can use to make them stick together instead of bounce apart. And I've got then this clicker quiz for you to do. When I look at those force sensors and run the carts into each other, will the forces always be the same? Will it depend on if I've made one cart heavier? Will it depend if they bounce or stick? Or will it depend if I make them run into each other as they're accelerating? Okay, so go ahead and lock in your choice here. I'm just going to run them into each other. So here goes. Okay, I can rescale the axis here. So does that look like they are equal and opposite? Looks that way to me. Pretty identical. Okay, let's do another one. Okay, I'm going to leave this one stopped and this one's going to run into it. Still equal and opposite? Okay. How about if I do it the other way? If I run this one into there? Oh, it went off scale again. I can fix that. Okay, still equal and opposite? Looks like it. How about if I make one of them really heavy? I have to do this carefully because these things don't really balance very well on these carts. So I'm making this one, the cart itself is about 500 grams, just over 500, and I just added 1,500 grams to it. So this is now 2,000, which is 4 times heavier than that one. And does it matter? Still equal and opposite? That was kind of a whippy collision. Let's try that again. I don't know if there's a better way to balance this. Not really. Okay. Let's do the mosquito scenario. Remember that this is the truck, this is the mosquito. It's a mosquito that weighs a quarter of the truck, but I'll let that slide. So maybe I'll add that one in back. And this one up here. Okay, truck's coming down the road. Here comes the mosquito. And how about that? Are they equal and opposite? Yay! Physics works again. I'm sorry I broke physics for a little bit. And how about if they stick together when they collide? So I'm going to add some clay here, and then start that going. So now this time they're going to stick together. Oh, they didn't stick. They popped off. But that's okay, because physics doesn't care if they actually stick or if they don't stick. See how they're still equal and opposite? Even though they do weird stuff, right? They're still equal and opposite. And in fact, I can just push them together with my hands, for that matter. I can go like, oh, I need to start the thing going again. I just got these sensors, well, the department got the sensors about a month ago, so this is the first time I really got to play with them. Okay, so slow motion collision. Okay, so still equal and opposite. So hopefully I have made a believer out of all of you. Regardless of the situation, the forces are in these two sensors here are always equal and opposite.